thanks for having me, Dan. This is great. I'm going to kind of touch a little on what Kevin was kind of talking about, more so against an operator rather than what a CNC or one of those big machines do. And then also touch on what Catherine talked about earlier this morning, just about compliant tools and kind of what goes on there. And then a little about how to select abrasives. Not exactly which one you pick for each specific scenario, because that's large. So at 3M, we have a large amount of abrasives we use. We love what we can offer, and I think it really sits well with abrasives in robotics. So just to start, this is kind of a rough look at kind of, I think, what integrators look at and kind of how we can do at a very high level, talk to customers on if their application is good at, or a good opportunity to automate. Now, we can look at it part throughput. You got a lot of parts coming through, but if they are very inconsistent on the other end, it makes it very tough to automate. This is very high level, so we don't like to bucket it perfectly, but it's something that we can look at just as an idea of kind of where to start, especially if you're not in a lot of abrasive removal. It's been around a long time, but not many people know about it, so that's what we're here to try and educate on. So big one that we like to look at, part mix, but especially part variability. How different is part to part coming into the work cell? Because that really depends, it makes it easier or harder on how to manufacture. So keep it going. Biggest question we get that inexperienced integrators will ask is, how are you doing this project today? So I can stand there and look at an operator, see what they're doing. If they're doing weld grinding, for example, a lot of back and forth to remove the welds. And we'll have that inexperienced integrator try and just copy that. They'll look at it, how do we remove these welds without changing it up, use the same exact tooling. And we like to step away from that, step back, and really figure out why they're doing what they're doing, so we can really implement robotics to show the value of robotics rather than just try and copy something. What tools, what abrasives, what are your cycle times? But then we get down to, if you're more experienced, what are your automation goals? Why are you automating? Different things like that. But these are just some of the initial questions. So what we like to show off is simply automating what is done manually. You can really, you can miss out on a lot of opportunities for what robotics can do to improve your process, make it better, more consistent, and whatnot. So many applications for abrasives can be a lot different than manual operations for robotics. And the thing we like to talk about, again, is what is the incoming part? What does it look like? What are you trying to get out of it at the end? Down at what manual operators can do, they can react quick, they can move, but they can also create more errors. So a lot of times for, let's say, weld grinding again, I work with MetFab, so that's why I talk about weld grinding a lot. I spend a lot of time there. It's also stainless deburring, stuff like that. So that's why I bring up weld grinding a lot. But if you look at these parts over here, these are just some demo ones that we've had. You have some welds that are on there, you get a finish, and then a powder coat. Now in a manual operation, a lot of powder coating has random orbital sanding involved. Takes a lot to switch those discs, those pads, but what it does is it breaks up the scratch patterns that a operator adds, so that it creates a nice unseen scratch pattern on there. So when you cover it with powder coat, you can't see, but with robotics, you can create a nice clean, smooth finish so that it's not necessary to use random orbital sanding in all applications, not all of them. But we're looking at what comes in, what do you want to get out of it, so what are your finish requirements, why do you have these requirements, and then kind of find the solutions in between. Reasons you don't want to necessarily replicate manual operation is because robotics, you can do a lot more with them. You can lift big heavy pieces that an operator can't bring up to a back stand. They're very repeatable, as talked about before. There's a much larger amount of abrasives that can be used with robotics. Right here I show a nice large part going up to a back stand with a belt. The belt is removing some flash, where an operator can't carry a big belt machine, or they're not going to lift this big part up and bring it to a belt. Belts last a lot longer because there's more abrasives there. So in a robotic cell, you want a lot of uptime, so it's always running. And every time you have to stop to change a belt or change a disc, just adds to or it takes away from the amount of productivity you can get done. So that's just a quick example. There's all these ergo benefits and labor benefits just because you don't have a lot of people these days that like to grind, spend a full day grinding. So it's leaning more towards this industry to automate grinding opportunities or polishing just because not many people want to do it. So it's kind of giving a big push towards jumping there as well. So here's two videos, same exact part. We have a manual weld removal next to a robotic one. I'm going to try and have them run at the same time. So let's see. There we go. All right, so kind of what that showcased, the operator on the left side here, he's using a very steep angle, grinding really quickly, but then he has to go touch up all the spots he missed. Takes time to look, check things out. On the right side, we have just a weld grinding with a fiber disc. We're able to run it very flat. The benefits of being able to run it very flat is you get to use more of that disc. So when an operator is running on a very steep slope, you're using the outer ½ inch of that disc. And with robotics, since they're rigid and strong, you can run it as flat as you want without, as long as that center nut isn't hitting your weld, you can keep it that low so you can use a lot more of your abrasive. The consumption's better. And also you can look, it's a nice clean finish. It spreads out nice. If I would have brought some parts, you can feel that it's not actually undercutting or creating problems. On the left, there's different waves you can see, so it's tougher to powder coat. Just a couple differences, but hopefully that showed off some stuff. So next thing to go to is how are you gonna process this part? Are you gonna pick up the part with the robot, bring it to a back stand? Are you gonna bring these abrasives to the part? A lot of stuff goes into this, but the biggest one is just look at the part. What are you trying to do to this part? Are you deburring it? Is it massive where you got to have the robot on a track going back and forth? A lot of times that is the easiest decision maker right there. If it's easy, you can pick it up, move it around, then it adds a little complexity on what actually abrasives are you trying to do. Are you grinding, deburring? Are you trying to polish with some of our Trizac belts? We have huge portfolio, so the biggest thing is looking at the part. Then you get down to, at the end, what kind of finish are you going for? So that's where we at 3M like to step in and help out. I'm being very broad, so any other questions you have on specific stuff, pull me aside later. We can talk about it, but hopefully this is kind of hitting those high points on how we go about. So. Force control is a big thing that's been talked about. ATI is here. There's other force controls devices out there. And what that does is it gives the robot a sense of feel. A sense of touch is kind of a high way to think about it. So what it can do, you got your force torque sensors, and the ATI device is there, belt machines, back stands. It allows for a little part variability, but a consistent finish due to force control. There's two types of compliance that we talk about at 3M and in the automation world: passive compliance and active compliance. easy way to think of passive is it's kind of like a spring or a air shock you're pushing up against. It's just kind of going with the flow. But the biggest difference is the compensation of gravity. So active devices compensate for gravity. So as you rotate that abrasive around or the tool around, it will compensate for gravity. So if I want to put 5 pounds of force down this way, I can. I can also put 5 pounds of force this way, and it can calculate and make those changes there. Lots of different tools out there. Benefits of some versus others. It really depends on what you're trying to accomplish in what space you're accomplishing these things in. So that's just the easy way to do it from afar, I guess. Now I'm going to show you a couple different videos. This is a video of a tool with active compliance. It's going to show going around a corner, removing some welds again, but kind of shows off how you can get a different finish, not just on a flat surface, because like talked about before, most surfaces are not flat and easy all the time. So. This is an example of a electrical cabinet, electrical box. If you look at it, it's just a cube, which isn't really in industry at all, but that's kind of what we're doing here. And then it kind of does this through the rest of the part. So I'm going to skip forward after one more here. Here's an example where force control is not needed. This investment casting is probably not the only, but the biggest area where you actually don't need force control. You're getting a part, you're getting it down to a very thin witness, then it goes into a CNC mill. This is actually a knee here as well. You take the large gates off. We're not cutting any bones, but this is for minor surgeries, I guess. But it goes to a witness, then it'll actually go into a CNC where it gets precision ground down, and then it'll go through a series of Trizac belts to make it cleaner, easier finish. But we do have an ATI force torque sensor on there. This is in our lab in St. Paul as well. We use this so we can monitor how much force we're applying to the belt. We can predict when to add forces, how much force is needed, but here we go. So you can see there's a little witness left on this part, but it continues. So. Where 3M comes in, you saw those videos, that's proof of concepts we do up in our lab. Myself, along with 3 other of our AEs up there, we use our premium products to provide different solutions for end users to help out integrators like Dan here at ARC. We have products that cut very consistently. They're long-lasting. They're predictable, which is big in robotics as well. We talked about it a little before when the ready-to-grind conversations popped up. But if you can predict when they're going to dull out or when you need to increase the forces, you can add that to your robot cell just with your programming. So that really helps optimize life of your cell and can help with ROIs and stuff as well. The performance and then the quality, so getting that quality finish that you're looking for. Trizac. It's our micro-replicated grains that used a lot for polishing, mirror, clean finishing. Cubitron 2, which is our precision shape grain. We use that for weld grinding, also shown in that on that belt when we were doing that aggressive grinding, gate grinding. And then Scotch-Brite, which is a huge portfolio of non-wovens that can be used for deburring, finishing, even just changing what the finishing looks like. So it's just making a matte finish on something. with the abrasives, that ties into compliance is conformability. They go hand in hand, but basically what it is how squishy, I guess you could say, your abrasives are. If you look on the left side, they're very non-conformable parts. They're very hard, and they often create a more aggressive finish. We can change backup pads, you can change different wheels, but if you look on the right side, we also have different products that are more conformable, make it easier to help program, so all this point-to-point programming is not as necessary, especially when you add compliance in there. Yeah, so it can help assist in part contours and stuff without having to change your programming too much. So here's a quick picture of our lab. Up in St. Paul, we have 3 different robots. We got a ton of different compliant tooling where we can go in and swap things out, change stuff around. We also have a bunch of abrasives there. We get proof of concept work sent up to us. We invite customers, integrators to come up to our lab, actually work with us on their part, on their project. They can see it work. A lot of times if you look at a picture and try and replicate that picture without any input from the quality or whoever is working on it, it's very hard to mimic. So we really like when customers come up and visit our lab. We are getting new robots, new equipment all the time. Well, not new robots all the time, but we are getting new robots. So if you guys come up to the RIA conference, or if you're interested, you'll see new equipment in there, and it'll be a good time. So just the 3M value prop right at the end. We have our application expertise. We have 11 different robot labs throughout the world, a bunch of different application engineers focused on robotics. So if you guys have coworkers or other facilities across the world, we can help out there as well. We have a large integrator partnership that ARC's a part of, and that we're trying to grow so that more people learn about abrasives, how to use abrasives, because if we can step in, show people how to do it correctly, how to use our abrasives optimally, you get that word out, and I think the whole industry grows with that, like Catherine talked about earlier. So that's what I got.